Hello, AP Calc BC. This is the second video or the second lesson of these hyperbolic trig functions. So in this video, I'm going to be doing some more examples, and then you'll have an assignment to do after this. So what I want to do today are some example problems from page 572, numbers 16, 26, 28, and 30. So number 16 is pretty straightforward. For those problems, this comes from the section of problems from numbers 15 to 24, and the directions are to say whether those are even, odd, or neither. And those are pretty straightforward. You can actually just, for that, you can just go look at the graph. And number 16 is asking about coth x, and so I copied the graphs from the trig functions into this OneNote page right here, and if you look at my graph for coth x is right here, and so it's this piece up here in the first quadrant and this piece down here in the third quadrant. And just from looking at the graph right there, we can see that coth x is symmetric across the origin. And so if it's symmetric across the origin, then it has to be odd, okay? And so your answer to number 16 is just odd. So then I want to go ahead and do number 26. So this is coming from page 572. And so for 26, you're given the problem tanh x equals 3/5, and you have to solve that for x, okay? Now, there are a bunch of different ways that you could go ahead and do all of these. So you might go ahead and you might get the same answer I do, get the correct answer and do it a different way, and that's completely fine. How I would do this one is I would rewrite it in terms of sinh and cosh. So I'm going to take tanh, and I'm going to rewrite that in terms of sinh and cosh. And so that's 3/5, and then I can throw my exponential identities in there. And so sinh is going to be, that'll be 1/2 e to the x minus e to the negative x. And then cosh is going to be 1/2 e to the x plus e to the negative x. Okay? And then I could go ahead and cross multiply and distribute those 3's and those 5's. And first off, I could see that the 1/2s would cancel right away, right? And then I could go ahead and distribute those 3's and 5's. So then in my next step, I would have 3e to the x plus 3e to the negative x equals 5e to the x minus 5e to the negative x. And then what I could try to do is I could try to get all of my e's to the positive x on one side and all of my e's to the negative x on the other side. So let's see. Let's go ahead and subtract this 3e to the x, and let's add this 5e to the negative x. So then on the left side, I'll have 8e to the negative x, and on the right side, I'll have 2e to the positive x. And then I'm going to divide both sides by 2. So I'm trying to get e to the x by itself, so I'll get 4e to the negative x equals e to the x. And then I could multiply both sides by e to the x, right? So if I have, let's see, e to the x multiplied by 4e to the negative x equals e to the x times e to the x. So I'm just multiplying both sides by e to the x. And so let's see. Well, on the left side, if I'm multiplying two things with the same base, right, I'm going to have this 4. But then if I multiply this e to the x and e to the negative x, well, those have the same base, and I could add those exponents. If I add an exponent of x plus negative x, that equals 0, so that cancels out. So then that just turns into e to the 0, which is just 1. So really all I have left on the left side is 4, and then on the right side, that's just going to turn into e to the 2x. So then I could take the natural log of both sides, and so I'll have natural log of 4 is the natural log of e to the 2x, and so then if I simplify that, I'll get the natural log of 4 is 2x, right, because my natural log of e will clear away, and so then I can just divide both sides by 2, and so x is the natural log of 4 over 2, and then we can take this one step further. Well, then this is the same thing as 1/2 natural log of 4, and if you have a coefficient in front of a natural log, that can turn into an exponent, so then this turns into the natural log of 4 to the 1/2, and that's 2, right? 4 to the 1/2 is the same thing as the square root of 4, which is 2, so then x is just the natural log of 2. And so that is your answer for 26. Okay, so the two other ones I wanted to show you were 28 and 30. So these can get a little tricky. Well, not tricky, but just there's a lot of steps. So for 28 and 30, we have to verify identities. So for these problems, because you're verifying identities, really, you're not giving an exact answer like we did in the last problem where we were solving for x and we were coming up with a specific value. You're just showing your work, showing logical steps, and getting, one side of the equation has to equal the other side of the equation at the end. So for 28, we have cosh u plus v equals cosh v plus sinh v, and we have to verify that. Okay, so how I'm going to start this, well, I'm going to start with the left side, or the right side rather. Okay, so I'm going to start with the right side of the equation, and I'm going to start working there. So I have my cosh u cosh v plus sinh u sinh v, and what I'm going to, and actually I just realized these u's and v's probably can be confusing. If I try to, that's a u, that's a pointy v, and that more of a rounded u. Alright, so what I want to do with these first is I'm going to rewrite everything using my exponentials. So this cosh u, this first cosh u right here, this first cosh u right here, we know is the same thing as e to the u plus e to the negative u over 2. And I did the same thing for my cosh v, and that's going to turn into e to the v plus e to the negative v over 2. Right? And I did the same thing with the sinh on the other side of the addition sign. I'm just rewriting it with my exponentials. So I'll have e to the u minus e to the negative u over 2 times e to the v minus e to the negative v over 2. So I've just rewritten everything in terms of my exponentials. And now what I could do, well, these denominators of 2, right? If we multiply these denominators together, we'll get 4, and then I have a 4 over here, so I could factor that out. So my next step, what I'm going to do is I'm going to factor out the 1/4, and then what I could do is, well, what we kind of have going on here is it's kind of like you're foiling e to the u plus e to the negative u times e to the v plus e to the negative v, right? So what I'm going to do is I'm going to pretend that this is one set of parentheses and this is another set of parentheses, and I'm going to go ahead and FOIL those out, okay? So my first foiling, I'll do that in red, and so then you can see what that looks like. So if I do my firsts, well, e to the u times e to the v, that just turns into e to the u plus v, right? Because if you multiply two things with the same base, you can add your exponents. So that's my first, and then my outers, well, then that'll be plus e to the u minus v, and then my inners, that will be plus e to the v minus u, and then my lasts, that'll be plus e to the minus u minus v. Okay, so that was just my first one. And then, well, I have a plus sign in the middle, so actually I don't have to stop with this set of parentheses. I could keep going. Let's erase that. And I'm going to FOIL these next ones in the same manner. So it's going to take up a lot of space, so I'll just move down to the next line. Okay, so I'll have a plus sign. And then, so my first, let's see, so my first, I'm going to do e to the u and e to the v. So again, I'll have e to the u plus v. And then my outers, that'll be a minus e to the u minus v. And then my inners, that'll be a minus e to the v minus u. And then my last, well, my last, that's a double negative, right? Because I got a negative and a negative. So that's going to turn into a positive e to the minus u minus v. Okay? So I'm going to go ahead and combine some like terms here. So I've got this 1/4 down here. And then I can see, all right, so I've got, let's see, do this in green. I've got an e to the u plus v here, and if I scan through my exponents, I've got another one here, right? So I've got two of those. So I'll have 2e to the u plus v. All right, now I've got my e to the u minus v. Oh, and I've got another one here, but it's negative, so then that cancels out. So those disappear. So I have an e to the v minus u, and I've got another one down here, but it's negative, so that's going to cancel again. And then I have this e to the minus u minus v, and I have another one down here, and it's positive, so then I'll have plus 2e to the minus u minus v. Okay? So now what I can do, let's see, is I can say, well, if I can cancel between this 4 and these 2's, right? And so this 4 becomes a 2, and then these 2's disappear. So then what I have is e to the u plus v plus e to the minus u minus v, and that's all over 2. And then if you remember, back from the beginning, from one of the identities that we went over, we said, if we think back to an earlier identity, we said that cosh x is e to the x plus e to the negative x over 2. And so if you think about what we have right here, right, if you think about this as one chunk, that u plus v as one chunk, and this negative u minus v as another chunk, well, this exponent negative u minus v, that's the negative version of u plus v. It's kind of like we took this u plus v and we threw a negative in front of it, right? And then that gives us negative u minus v, which gives us this exponent here. And so that's how we get this connection from this positive x to this negative x. So if cosh x is that, then we can say, well, then this is the same thing as cosh u plus v. And we're all done, and we have proved our identities. So when you do your work, you kind of have to show all these steps, because that's how you prove an identity, okay? So that's it for number 28, and then we'll go on to number 30. So 30 relates back to what we just did in 28. So the directions they give you on page 572, they say use the identities in 27 and 28 to derive the identities in 29 and 30. So for number 30, the problem that they give us is cosh u minus v equals cosh v minus sinh v. Okay? And so we have to prove that. So what I'm going to start with is, well, let's start with what we just proved above. So we can say from number 28, we proved that cosh u plus v is cosh v plus sinh v. So then if we take, okay, let's see. How do I want to say this? Okay, what we have in the beginning problem, what's different from what we just proved? So this in red. What we just proved has a plus v, but what we were given in the original problem, number 30, our task, we've got this minus v. Okay, so that's the difference. So we could think about this as cosh u plus a minus v. Okay, so that's how we can kind of relate the two. So then if we do that and keep writing, well then what that's going to give us is cosh u times cosh negative v plus sinh u times sinh negative v. Now, we know, we talked about on our first day some factors or some qualities of the cosh function, and we said that cosh negative v is the same thing, it's equal to cosh v because cosh is an even function. And we said that sinh of negative v is equal to negative, write this a little more clearly here. Sinh of negative v is equal to negative sinh v because sinh is an odd function, right? So then if we take these facts and then what we have going right here, right? If I kind of rework some things, we could say then that cosh u plus a negative v, well, that simplifies to cosh u minus v. That makes sense, which is cosh u cosh v, right? Because cosh of a negative v, this is even right here, plus sinh u, or I'm sorry, not plus, minus sinh u sinh v, because this sinh minus v right here, this is odd. Okay, so you have to show those steps, and that's how you would prove number 30. So those are the examples for today, and then hopefully you can go ahead and try the next few assignments now that you know all of that.